So let's start with the bottom-up approach again. And as we have seen in the previous problem that we have solved, that for the bottom-up approach, we start with the base case first, and then we proceed with the higher level cases. And we try to see that whether we can deduce any algorithm or pattern and reuse the results of the sub-problems that we have already solved. So as discussed, then let's start with n is equal to 1, which means that we are given a string of only length 1, and what are the maximum number of possible strings possible using the rules given there. So as we have seen already in this output, that if n is equal to 1, output is 5, because we can choose all these 5 vowel characters once, forming one string individually. So if I just place it here, so the possible number of strings would be A, E, and the count would be 5. So if n is equal to 1, our answer is 5. Now let's go with n is equal to 2. Okay. So for n is equal to 2, again, we have seen in the example here that e's are following these rules. These are the strings possible. But let's write it down here. So A can only be followed by E. It means that our string would be, first string would be AE. Okay. Similarly for E, it can be only followed by an A or an I. So let's write it down here. So if E can be only followed by A, which will give me string as EA. And the second possible is E can be also followed by I, which will give me E I is equal to EI. Okay, similarly, I fill it for other I, O, and U. We got 4 strings possible when we have got I first, because it can be followed by everything except I. We got 4 strings here. Similarly for O, it can be only followed by I or U. So we have got OI and OU. And finally for U, it can be only followed by A. So it forms UA. And if we count all the strings possible here, so their total number of count is 10. So 10 is for n is equal to 2, our solution for if we have got a string of only length 2. Now, do we see any pattern here? Because as we said before, that for bottom-up approach, we want to see that if we are seeing any pattern, and if we can, say for n is equal to 3, whether we can reuse the solution we have already got for 2. So here, let's revise this again. So we see that when the last character here for n is equal to 1 is A, then only we make a decision that what would be the next character possible, because just based on this last character A, we are actually having these rules that A can be only followed by an E. So if E is the last character for the previous substring, for example, if we have got here in this case, we have got AE, right? So after A, once we have this AE, and once we want to form n is equal to 3 from this AE, so we just choose that E is the last character, and what are the possible characters for the length for the third position here after E. So it would be AEA, or so for AE it would be AE of A or AE of I, right? So these are the strings possible when we have got the last character from the previous substring, from the previous subdomain problem. If we have got a last character as E, then only we can have this decision of creating 2 strings. Similarly here in this case also for EA and EI, so we go with the last character EA, this one, and we see that for the rule again we can have only EAE, right? Because the last character for A, we have got this rule that it can be only followed by E, so it would be EAE. So the whole formula, we can see a pattern here is that whatever the strings that we have formed from the previous subdomain problem, it's only based, all the rules are based on the last character. It's only like this character, or if I'm treating with this string, we are treating with this character. So this is how, we see a pattern here. So let's actually, to better visualize it, I will create a 2D array to just explain the same concept again.